fish, it's something that they use. It's something that they interpret natively to them. We interpret numbers natively because it's something we use. Aliens may not. So they may have a better system for math than we do. So it's easy to understand our problems. They're not intuitive. For example, searching. Searching is very hard. Trying to emulate the human brain is very hard. It's not intuitive. That's just we don't understand how the human brain is something we interact with directly like that. So like the best attempt we can make at the human brain is making a bunch of paths and a bunch of circuits that go different ways based on how different things interact, which is sort of a very difficult concept to wrap your head around, which is why we have such difficult times with AI right now, which is why a lot of AI is probabilistically based. A lot of AI is computationally expensive, because we don't have the ways to understand the human brain and how the human brain decides things. And actually, I've been told by many people who work in AI that understanding the human brain is actually one of the big setbacks in AI. People waste time on. That's not actually so important. So, with abstraction, we can solve a lot of these problems pretty easily, or at least we hope we can. Can abstraction be bad? Yes, in certain circumstances, like if you're writing a program that needs to define prime numbers, you don't need 6 layers in there to help find prime numbers. You can write one function and call it a day. People will write abstraction for this, for finding prime numbers, and that's totally fine. However, they're not going to, in the future, need to make a compatibility for this. They're not going to. So the point of abstraction is that later on something changes, something small changes, not everything is wasted, not everything will go to the trash bin. In some circumstances, abstraction isn't really is kind of overkill. But for the most part, it's totally fun. Yes, Charlotte.
You should go to the FizzBuzz Enterprise repo. Have you seen that?
No, I haven't. Oh, well, let's check it out.
This is literally exactly what the point is.
Is it like a TensorFlow example for FizzBuzz?
This is way better.
Enterprise quality coding. Source I should go to? Or where should I go, Charlie?
Just click around and see what you find.
Okay, let's go to package name.
Just try to find the logic.
Okay,
that's what you're doing here.
Okay, so FizzBuzz is a pretty simple program. It checks the numbers divisible by 3, divisible by 5, or divisible by both. And it gives you an output based on that. It's basically the core, the de facto standard for seeing some action is Fermi logic. You don't need at least 6 folders of code to do this. No one does. And it is abstraction, it is overkill. But hey, you know, if we ever change this problem, this code probably will still work. And it'll probably require a very minimal change to fix. But of course, at the same time, no one wants to maintain this code and no one wants to even see this code. That's why I'm not going to go any further.
You just look in the main func in the main.
Alright, arithmetics. Integer divider. Okay, integer division is pretty much given anyone, so I don't know why you need a class for it. So there's lots of imports. There's a service. There's some logic that happens here. And it does a lot of handling for some division, which actually happens right here. This is the entire line that actually is necessary right here, the only line. So there's 49 lines, and you only need one of them, really. That's a 1 in 49% waste of time. And there's about 6 more folders, so as you can see, abstraction is sometimes bad.
There's like 120 files in this repo.
There's like 120.
It's like almost 1,000 lines of code.
Yeah, so as you can see, abstraction is cool, but some people will overdo it. I myself am guilty of overdoing it. I've written some programs and I've added abstraction for no reason. Because I thought to myself, maybe in the future I'll need to change this. And so I wrote the code, I never touched that code, and it has worked fine. But the hope is that one day I will write a program that will use a network interface. And maybe the network interface will change just in the slightest bit, and I won't have to rewrite the entire application. And that is the hope. But until then, I'll keep wasting time with abstraction, because it may not ever happen. Blenders do not belong next to your bed, Jim. That is going out to Jim.
Does Jim have a blender next to his bed?
No, he doesn't, but he might one day. So here's a comic I found on Facebook. A comic, not really a comic. Some dudes will install links on anything. This farm runs Debian. That's the Debian logo. For some reason, chickens are assorted in a Debian logo, and someone is pretty clever. People do go overboard with programming. It's a pretty common thing. They will install Linux on toasters. It is a common joke to install Linux on a toaster. It has a circuit board, maybe. You can probably install some sort of kernel on it. Linux is small and portable, not really small or portable, but it's open source, so you can probably try to get something running on it. Programmers do the wrong thing a lot of the time. And I've already with Jim about this. This is the example I've given to Jim. That when you're writing some code and you find something that's convenient to put somewhere, you just put it there. And don't do that, because you have blenders in your bedroom soon. Like the blenders belong in the kitchen, they belong there. It's convenient to wake up in the morning and have a smoothie, sure. But you you can walk downstairs to the kitchen and get your food blender right there. Otherwise, sooner or later, you have your kitchen knives in your bed because you're making food one day. It's convenient to be there. You can cut food now in your bed. It's super convenient. But it doesn't belong there. Don't do this. And this is one of the biggest issues programmers have. They put things wherever they feel like. And it produces terrible, terrible code. It's unmaintainable. Bad programmers put convenient things in convenient places. Yes, sure. So suppose you're writing a SQL wrapper and you want to check the version of SQL. You put a network request in your SQL wrapper that's now doing data. So now your database manager is doing network calls. Why is this happening? You don't need this to be this way. This is bad. Because now you're introducing bugs where they don't belong. And like now you have dependencies elsewhere. Like this has to, now your databasing stack has to worry about networking for some reason. Why does that need to occur? Everything's local. Convenient place is not always the correct place. This is a local problem. So like if you're in a certain file and you think it's convenient to put it here, it's probably not convenient. If it's convenient to put it there, it's probably not the right place to put it there. Convenience does not always need to be correctness. Correctness does not always need convenience. However, on a global scale, the most convenient solution will probably be the correct solution. So if you have a network function somewhere that's kind of hard to get, it'll probably be easiest to get for everyone instead of just easiest to get for one person and harder for everyone else. So keep strict to your organization. Keep your blenders in the kitchen. It's where they belong. It may be inconvenient to walk downstairs, but it's worth it. In the long run, at least. If someone asks you for your blenders, you have to walk upstairs and not get your blender. Everyone's kind of like looking like, why are you doing this? XKCD, once again. I could restructure the program's flow or use one little go-to line. It's convenient. Why not? Screw it. Screw good practice. How bad can it be? Let's put a go-to function. Our go-to things aren't terrible, but regardless, go-to means of 3 compiles and then filing it, and then a dinosaur attacks it. And this will happen if you write bad code. So, XKCD, of course, has captured what I imagine to say much better. You should restructure. Please. Please restructure your code. Qualities for good programmers. Qualities of good programmers. So, it's sort of hard to talk about good programmers in general, and good programming in general, so I've sort of broken it up into bad programming, bad programmers, good programming, good programmers, because there's definitely a big difference. Bad programmers can write good code. Good programmers can write bad code. This code right here is written by a great programmer, and I don't think it looks good at anyone. It actually animates a donut in your terminal, but the code is shaped like a donut too. And it's very illegible. You have no idea what's going on. Like there's some sine and cosine functions, but I have no idea what's happening, honestly. And it's a pretty famous example from like an obfuscated C code challenge. It'll render a donut. Actually, I'll pull up the donut. Why not? So here's the code I copied or I screenshotted, and it'll animate it. And it'll do something. You can compile this and run it in your terminal. Like there's a variable here that says K. Like there's no type. I don't know what this is. And then you look at this code, there's no idea what they're looking at. It doesn't make any sense. But it animates a donut, and it's beautiful. It's absolutely glorious. And good programmers have a tendency to write bad code. It's not even. I don't even know what to classify this as. It's not bad code. It's not. I don't know. I have no idea what this is. And of course, quality is good programmers change from language to language. Like I'm sure things that I think are good in C, I think are disgusting in Rust. And that's pretty much guaranteed, because the divide between C and Rust. Good programmers. Good programmers are generally easy to pinpoint. They said there's a quote on Hacker News somewhere that says good programmers are impossible to find. Because once they found their job, employers will not let them go, because they know how good of programmers they are. So once they have found a programmer, they're not letting them do whatever they can in their power to keep that employee happy. Which is why it's impossible to find good programmers. So it's technically like a myth. Either good programmers don't exist, or the managers have noticed them and they're not willing to let them go. Good programmers stick to a small few languages. There's exceptions. I know a professor at UC Santa Barbara who knows absolutely everything about every language I can possibly name. He'll program in any of them at any given moment. I don't know how he does it. I can't do it. I don't know anyone else that can do it. I know 2 other people actually that I can probably compare, but basically the best programmers are the best programmers at their language, at their art. Just like the best painters are good at painting and not necessarily drawing. I mean, maybe drawing as well, maybe not sculpting. The best artists that are better at sculpting may not be very good painters. They generally excel. Like, they know everything there is to know about the language. They are just good at it, that's what they do, and that's how they stay good at it, because they don't move on anywhere else. Which is fine, honestly. If they're good at what they do, then don't make them move. Like, I'm saying change is good, and change is fine. Change comes when it needs to come. But the best programmers usually stick with what they're good at. That's totally okay. Good programmers can give you obscure trivia about any language they're working in. I bet Owen can name like 4 facts off the head right now about Rust that no one else knows in this room. I can name a few about C, and I use C like every day. I know people can name about Python. Clark can name quite a few about Python. I'm sure Charlie can name a few about Python. Like, people who work in their languages, they've learned these little obscurities, and after a long enough time, they're like a friend. It's like something. It's like a piece of trash in your house that you walk past every day, and you're like, I know that's there. And like, someone can ask me, and they're like, yeah, I know that soda can's in the corner of my room at home. And they're like, how do you know that there's a soda can in the corner of your room at home? Like, I see it every day. I know it's there. I recognize it. I'm not gonna move it. It's disgusting. I know, but it's gonna be there. And that's programming language. Programming, like, I studied JavaScript. There's garbage cans in the corner of your room that are just full. JavaScript has plenty of those. I've been teaching. You have a question? Oh, okay. Sorry. I've taught programming to several people. I helped out with the computer science course in high school. And for the most part, I know that when you're coming to teach them computer science, the simplest thing that they're going to try, it's not going to work. Because programming is such overhead. Like, you want to try something so simple, but now there's like little semantics that you have to know to get something to work. And you're like, you know these semantics because you've done these simple things and you realize why they don't work. Like, to write a simple program in C, you can't just type main and return 0. Like, that would make the simplest sense. That's the simplest possible thing to write. Sometimes it doesn't work. So, those programmers know these semantics. They know what's wrong with the simplest things. Unfortunately, the simplest things never work. They do work sometimes, but the best programmers will know about them. They will know that they exist. Examples of some intricacies. So let's define an array in C. The array sub the first element, or the one element, which is actually the second element in the array, is actually equal to the arrayth element of the number 1. You know, what does that mean? A 1 isn't just a number, it's not an array. That doesn't make any sense. So C actually has commutative math. So like array sub 1 is actually equal to a pointer to array plus 1. Because moving over one space of where the integer is located. So, since you can switch these two, since addition is actually commutative, 1 plus array and array plus 1 are the same thing. So 1 sub array, it actually is